So I tried recording this in class and it would not save this video. So I'm really hoping that by the time I get done with this video that it really saves. So I'm going to record this again, but I already have the work shown on here. So this video should go just a touch faster since I don't have to write anything. So I'll just go through this and I'll explain this to you how this all works. So 04, we did the first part of this on Monday, okay? So I've recorded the second part in class and that video is posted also. So we only get to about here, okay? We only get to about here before part 1 is over, all right? So this is just part 1 of 04 counting, okay? All right, so we said that, I'm delayed here, there we go, okay. We said that in this multiple choice here, the result of a single trial, I'm really delayed, I don't like this. The result of a single trial was an outcome. So we said letter C. The set of all possible outcomes of an experiment we said was B, a sample space, okay? So I talked a little bit more about sample space also and said that, like, if we're dealing with a coin, okay, this is how you list out the sample space for a coin. So if I'm flipping a coin, I could only get a heads or a tails. Those are the two outcomes that I could get. If I'm doing a dice, I have 1, 2, 3, 4, 5, 6. Those are the possible outcomes that I can get for a dice, right? Then it gets a little bit more complicated when we start dealing with like 2 coins, okay? So if I flip 2 coins, I could flip a heads and a heads and a tails and a heads, or a tails and a tails. Those are the 2 possible the 4 possible outcomes that I could pick, okay? So these are all called sample spaces that are listed out. It's just listing the possible outcomes that I have, okay? They also have like blood type down here. So blood type, there are 4 different types of blood type: A, B, and O. But then within each one, I can have like A positive or A negative or B positive or B negative, etc., right? And listing all of those with the RH factor, here is the sample space that I have. There are 8 outcomes: A positive, A negative, B positive, B negative, etc., right? Okay. All right, so there's another listed out sample space, okay? A process involving chance is the third one, and that is a probability experiment. And then D is used to systematically list the outcomes in a sample space. Sometimes you'll use what's called a tree diagram, which is kind of what this looks like. This is like a sideways tree diagram, okay? So that's part D, all right? Now, in the counting techniques, okay, this is all probabilities, or getting us ready for probabilities. In the counting techniques, there are 3 different ways that we'll use counting, okay? Way number 1 is called the fundamental counting principle. So this is number 1 way, okay? Number 2 way is permutation. So I had them put a little number 2 down here, and combination is the 3rd way. So kind of like when we did factoring, what you're going to do is you're going to look at one of these problems and you're going to say, which of these 3 am I doing? And then it makes it really easy from there, okay? So after you've determined which method to use, you're going to it's just going to be really easy from there. So fundamental counting principle is the first one. Easiest one of all 3. Fundamental counting principle says over here like this: I had 4 blood types, but within each one of those there were 2, a plus and a minus. So 4 times 2 makes 8. There are 8 total possible outcomes that I could pick, okay? All right, this is another example of fundamental counting principle. So a bicycle manufacturer makes 21 speed and 24 speed bikes, okay? Don't let the 21 and the 24 confuse you, because those are just 2 different types of speeds that are listed, all right? Stay quiet, algebra. Shh. 21 speed and 24 speed bikes, okay? There are 7 different colors and then 4 different frame sizes. So those are different categories. So if I want to figure out how many different bicycles can be made, maybe I want a 21 speed bike that's pink and then like 10-inch frames or something like that for size. That's just one combination, but how many combinations total are there? I just multiply all those together. 2 times 7 times 4. Okay, that's what it says for fundamental counting principle, multiplying the number of possible outcomes for each event. So that means there's 56 different possible bikes that can be made out of those different options for each one. Okay, now, in addition to that, this is also a fundamental counting principle. So let's say I have 5 players with jersey numbers 1 through 5. Okay, so my first player, if they're going to pick their jersey number, my first player can pick from 5 different jerseys. That's this guy right here. They can choose 5 different jersey numbers. So the person in class that was the first one to picked the number 3. Okay, the second person only has 4 jersey numbers to pick from. They picked the number 2. The third person has 3 jersey numbers to pick from because these 2 are already chosen. They picked the number 4. Algebra! Shh! The 4th person only has 2 numbers left to pick from. They chose the number 1, and the 5th person, they just get what's left over, so they only have 1 jersey number to pick from, right? So the combination 3, 2, 4, 1, 5, that's just one combination of assigning jersey numbers, and there are 120 possible because we multiply all those together. Okay. Now we did another thing that was like lunch numbers. Okay. At Blue Hill, the lunch numbers, there's 4 lunch numbers. Okay. So the 4 lunch numbers can be any number 0 through 9. So it could be a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. All right. Any one of those numbers. Okay. That is 10 if you include 0. That's 10 possible numbers that could be in this first slot. 10 possible numbers that could be in the second slot, 10 here, 10 here. Okay. So maybe that number is 6, 7, 4, 2. I have no idea. Okay. Maybe that's your lunch number. So we need to know how many total possible lunch numbers can be made. So if 10 can go in each spot, 10 different numbers could go in each spot. That is 1,000 different numbers, different lunch numbers, before we have to start repeating lunch numbers over again. So if I get to 1,000 students in the school, I'm going to have to do something different, like maybe add a 5th digit, and then that would give me some more combinations for, oh, excuse me, wrong. That should be 4 zeros, so 10,000, sorry. As soon as I get to 10,000, then I have to start repeating. I've dropped a 0, sorry. 10 times 10 times 10 times 10 is 10,000, okay? So if I get to more than 10,000 students, maybe I have to add in a 5th digit or something like that, okay? Now, if they say that the digits can't repeat, so like I can't have the same number over again, then 10 digits can go here, but this one can only be 9 digits. This one can only be 8 digits. This one can only be 7 digits. So it kind of restricts it there, and I would do 10 times 9 times 8 times 7 instead of 10 times 10 times 10 times 10 times 10, okay? So that's kind of how that works. Now, if I'm doing a question like this where it's 5 times 4 times 3 times 2 times 1, that's the same thing as 5 factorial, okay? So on your calculator, you have a button that has 5 factorial, so you don't have to type each one of them in. Algebra! 5 factorial, okay? So on your calculator, my calculator is dead here, but this is the calculator that you use, okay? You're going to type in the number 5, and then you go to this math button here. Everything's under the math button, so you hit the math button, and at the top over here, you're going to have a button that says PRB, and if you go over here to PRB, hit enter, and then you go down to like this little exclamation point, okay? Your exclamation point, you're going to hit that, and you're going to hit enter, and it's going to go ahead and give to you that answer is 120. So there's 120 different combinations. You can find that out by using the 5 factorial, okay? So that is like the fundamental counting principle. Fundamental counting principle, okay? This is another one, fundamental counting principle. So there are 8 finalists in a band. How many different ways can the bands be ranked if they cannot receive the same ranking? So the first place can be awarded to 8 different teams or 8 different bands, all right? Once that first place has been assigned, I only have 7 different teams that could go, or 7 different bands that could be awarded second place. After the second place has been assigned, there's only 6 teams left. After the third place has been assigned, there's only 5 teams left that could go for 4th place, and on down, right? After I've assigned places 1 through 7, there's only one other place that could be the 8th place, right? That's the same thing as 8 factorial. So if you type that into your calculator, you don't have to type 8 times 7 times 6 times blah, 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 all the way down. You can just type in 8 factorial, and it will give you this number. So there are 40,000 different ways that I can award 1st through 8th place to 8 different teams, okay? All right, the next thing is permutation combination, and this is where part 2 of the video picks up. So second way is permutation, third way is combination, and I start talking about those when we get to the part 2 of the video. So go from this video straight to part 2, and then you can watch the rest of that. So what we just did, what I just talked with you about, is what we did on Monday. Tuesday is this next part, okay? So I'll post both of those, all right?